Hi, and welcome to this video on applying L'Hopital's rule. We're doing the tougher problems. You should have already watched the first video, which went through the explanation and example of applying the more challenging form of L'Hopital's rule. All right, if we look at this problem, if we substitute in 0, which is always the first thing that you want to do, you're going to get 0 for the x value here. You're going to get 0 for the x value here, and in order to evaluate this limit, you need to think about what's happening to the graph of the natural log of x, and this is one you should have memorized. The natural log of x as we approach 0 from the right, so we're going to be approaching 0 from the right, we go to negative infinity. So this is going to result in negative infinity, and remember, anytime we have a 0 times infinity, this is bad. This is an indeterminate form that we cannot apply L'Hopital's rule to. So we want to change this function into something which will result into a fraction that we can then apply L'Hopital's rule to. So what I'm going to do is I'm going to force this x to go in the denominator. Right now it has an invisible exponent of 1, so I'm going to rewrite this as the natural log of x over x to the negative 1. So I've just used properties of exponents to move that piece of the function into the denominator. I can also rewrite this as natural log of x over 1 over x. So let's use this form of the function. We're going to reapply our limit. So I've got the limit as x approaches 0 from the right of the natural log of x over 1 over x. We already know that the numerator is going to be negative infinity, and the denominator, if we take 1 and divide it by something infinitely small but positive, we're going to get infinity. This is good, makes us happy, because now we can apply L'Hopital. So we're going to go back to our function right here. We're going to apply L'Hopital's by taking the derivative of the numerator, which is 1 over x, the derivative of the denominator, and I'm going to go back to this to take the derivative. We're going to get negative 1 over x squared. Then we're going to simplify this. So you get 1 over x, we're going to multiply by the reciprocal, negative x squared over 1, which results in negative x, and now we're going to apply the limit again. The limit as x approaches 0 from the right of negative x is 0. So we are done. We've got our limit. This limit has a value of 0, but we're going to arrive via this route. All right, I hope you like this example. I've got a few other examples I would like you to watch, so please make sure you see examples 3 and 4 that go along with this concept.